Question 8. A company prepares their shipments in two different sized shoe boxes. In order to fit with new shipping regulations, the company needs to decrease the volume of the boxes, and it will do this by reducing each of the dimensions by at least X inches. Which system of inequalities can be used to model V, the volume of each box, after each dimension has been reduced by at least X inches? So first off, the volume of a box is length times width times height. Let's take one box at a time. Let's take a small box. So this is we're reducing each dimension by X. So what operation do we use when we reduce? Well, we subtract. So that 12 inches we're reducing by X inches become 12 minus X. 8 minus X and 10 minus X. So that's my new length, width, and height. So I'm going to find the volume of the box by replacing the length, width, and height with those three binomial expressions. It doesn't really matter which one is the length, which one is the width, which one is the height, because we're multiplying these expressions, and it doesn't matter the order we multiply. But to do this, we want to take two of these expressions at a time. So let's take the first two, multiply them together. 12 times 8, 96. 12 times negative x, negative 12x. Negative x times 8, negative 8x. And negative x times negative x, positive x squared. Now I've got like terms here in the middle. So I'm going to rewrite this expression as x squared. I want to write the x squared term first. Negative 12x minus 8x is negative 20x. And then I'll put the positive 96 here on the end. So I'm going to now take that expression. I'm going to bring down the 10 minus x and multiply this trinomial times this binomial. Let's go back to magenta and distribute. X squared times 10. 10x squared. X squared times negative x. Negative x to the third. Negative 20x times 10 would be negative 200x. I can be careful here because there's a lot of basic arithmetic, but easy to make a mistake. Negative 20x times negative x is positive 20x to the second. And then finally distribute the 96. 96 times 10, 960. 96 times negative x, negative 96x. So we want to combine all of our like terms. I'll notice negative x to the third and positive 960. There are no like terms with those. So I'm going to put negative x to the third at the beginning, because that's the largest exponent, and positive 960 because we put our constant in the end. Look at the answer choices. It has to be either this answer choice or this one, because these are the only ones that lead off with negative x to the third. And they both have a positive 960 at the end, so the 960 doesn't help us rule it further down. Now let's combine our positive 10x squared and our positive 20x squared. This does rule it down further. This gives us positive 30x squared. This one has a positive 30x squared. The one above it doesn't. So this should be the answer choice. Let's just double check and verify. Erase all this so I can see that we do get all the other numbers to match up. Finally, negative 200x minus 96x is negative 296x. And yeah, that does indeed match up with this one. We don't even, thankfully, need to go through this process for the large box, but it would be the exact same process. We'd be multiplying the dimensions of 18, 12, and 14. We'd be rewriting them as 18 minus x, 12 minus x, and 14 minus x. If you want the practice, you can go and multiply them together, ultimately, you know the answer choice should be this expression at the bottom.